Welcome guys and gals, this is your host Frog Prince Rana and thank you for dropping by. This is a beginner's tutorial video showing how to model flat earth or globe earth for your videos and presentations. You do not need any prior knowledge, you will however need a 3D software. In this video, I will be using Blender, which is an amazing and free software available on all platforms. I have added all the required textures in description, but I will also show you how to create these images yourself. This video is time coded, so if you think it's a bit too basic, feel free to jump to next chapter. That being said, let's start. Installing Blender first. When possible, I try to get a portable version when using my Windows PC. Portable App website has several apps. This software does not leave file and registry all over your computer. If you don't like it, just delete the folder and you're back to where you were before installing. At the time of writing, Blender version 2.90.1 is available in stable channel. Once installed and launched, you should come across this window. First, let me show you the basic settings. By the way, I'm not a Blender guru in any way. The last time I was seriously using 3D was when Calgary True Space was a thing. So what I am doing, very much possible that there are better ways of doing it. If so, please let me know in the comments below. It would help others as well. The most important setting is under System, and it is Cycles Render Devices. Over here, you're setting if your graphics card is being used for rendering. On Windows PC, if you have a supported GPU, this is the way to go. I haven't tested it on OS X, but on Linux, I have been told that it is CPU that is faster. But on Windows, this brings a rendering from 4 minutes to 20 seconds for me. If you have a supported NVIDIA card, you should choose CUDA. For AMD cards, I believe it is OpenCL. Optics is still experimental and not completely supported. I have an old NVIDIA GT 1600, so CUDA for me. Next thing I like to change is an animation, and it is default interpolation. For a simple explanation, suppose I want the earth to rotate once in 3 seconds. If my target video is 30 frames per second, that means I need 90 frames of animation for this rotation. We will come across this later. In essence, we use what is called a keyframe. At a frame, I would mark the current rotation and value, and after 90 frames, I would rotate it by a positive or negative 360, depending which way I want it to rotate. And the software would figure out all the steps in between, which simply means, in this case, it should be rotated 4 degrees each frame. But the default interpolation mode is Bezier, which means it would be ramping up at the start to a constant speed and slow down at the end. Obviously, for most of this kind of modeling, I want a constant speed. Of course, individual keys can be changed, but I like it all linear, and then I change to Bezier if needed, instead of ensuring all are in linear. One more settings change, but this is personal preference. We will be using something called shader editor, where a bunch of boxes would be connected using lines. By default, in version 2.9, all these lines are straight. I prefer to have a little curve to make it look easier on eye. This is under Themes, Node Editor, Noodle Curve. I have mine set to 5. Use the hamburger menu to ensure your settings are saved. That is it. Once done, we are in a default scene with a cube in center. There is a lot of things going on and a lot of things that can be done. But don't worry, this is a beginner's tutorial. We will not touch a lot of scary stuff. Blender does support multiple monitors, and I have my render view on a second monitor where the first monitor is all for main view and editing. You can also dock multiple panels by dragging on the corners between panels, or right-click and choose vertical or horizontal split under Area option. To show the workflow, I will have the render view on the same window. So I simply split it in horizontal by right-clicking at the corner and change the top window to 3D viewport. Bottom panel is where I will do my editing. Things I would change on each scene. First, locate the property window. If not visible, open up a new window from Window Top drop-down and change it to show Property. Oh, by the way, make sure you're in Layout tab. First, in Render Properties, we get to set up Render Engine. Workbench is intended for fast rendering during workflow and is not designed for rendering final images. Then you have EEVEE or Real-Time Engine. It works great and super fast, but the quality is not as good as Cycle. For my rendering, I use Cycle. Maybe it's because other settings I have, but my night light looks much better with Cycle. Speed trade-off. Well, for my last video, I had to render around 2000 frames. That would come to a bit more than 66 seconds in final video. And to render that? Well, it took about 4 seconds for each frame to a total of around 2 hours 13 minutes. If I did it in EEVE, I expect that would have been done around 30 minutes. Using CPU, I guess it would still be rendering. If Cycles is chosen, please make sure device is set to GPU. Yes, we have enabled it in preference, but each scene also needs to set it. Then under Sampling and Render, I reduce render down to 32. In very simple terms, rays are traced from the camera into the scene, bouncing around until they find a light source, such as a light, an object emitting light, or the world background. And this is the number of paths to trace for each pixel in the final render. As more samples are taken, the solution becomes less noisy and more accurate. If I was modeling an interior or highly detailed scene, I would crank it up a lot. But for flat earth modeling so far, I have been happy with 32. 16 was a bit too low. Again, play with these settings and render a single image to make a decision. It is a compromise of quality versus speed. Another speed hack is under Light Paths and Max Bounces. For flat earth modeling, even 4 bounce may be 3 bounces too many. 12 is definitely overkill in my opinion. Under Output Property, make sure you're outputting the correct resolution. In my case, it is set to 1080p. There is a frame rate, but as I output all as images, this value does not matter to me. But if you want Blender to create an actual video, this is the settings you need to make sure is correct. File format? Well, if I don't need transparency, I would go with JPEG, as it would be much smaller in file size with 8-bit color depth. You might be tempted to go with 16-bit depth, but trust me, I'm pretty sure you won't be able to tell the difference. Next, under Scene Properties, I like to set up units. I obviously like to use metric system with length in kilometers, and I like to change the unit scale. This is used when you are dealing with microscopic or gigantic objects. The default cube you see has a dimension of 2 meters, so you can imagine how big that would be on your screen if it was same size as Earth. You would soon run into limitations with your computer memory and such, and it is a total pain. By using the scale, a value of 100,000 makes the same cube at 200 km, which I think is more manageable, unless of course I need to use the sun. Gravity is not used in this modeling, so all you flat earthers can relax. Next is World Property. With default settings, you'd get a grey background. I'm guessing we would either want black or maybe green. I will show how to create a cheap and dirty star fill later. Well, that is all the setup. Now let's talk about light. We need light to make anything visible. and 3D software can calculate reflection, shadows and such using ray tracing. There are 4 available light types. We have point light that behaves like a normal light, i.e., light going in all direction. Then we have sun, meaning all the rays are parallel. Then we have spotlight, and finally area, which is great to illuminate a specific area. Now we can move on to actual modeling. To start with, you need at least one image, and the higher quality, the better it would be at close-up. Also, it would help having all the distances and dimension handy. This initial image is traditionally called albedo or diffuse texture. A bit boring if you ask me. A second image would give it some ridges. Now, these are not random ridges, but based on actual elevation data of planet Earth. Basically, we have an image of Earth's elevation called normal, and we use it as a bump map. This gives it a nice look. Optional step? Well, now, when a light source reflects on our model, every part reflects back with the same shiny glossiness. But in reality, if viewed from outside, some part of our planet would reflect back a lot more than other parts. For example, the ocean should reflect a lot more compared to most land masses. So another prepared image marking the ocean would solve this issue. Next optional step, clouds. Now if you want static clouds, you can even use diffuse texture showing all the clouds. But I will show you to use it in a way where you can animate the clouds separately if you wanted to. This also means you can have the clouds casting actual shadows on ground, which is awesome. Next optional step, night lights. Well, night Earth looks lovely with continents lighting up, which is only visible from space when the sun is not shining on it. Well, depending on the camera and exposure, I guess. Anyway, another image for night illumination. Final optional step, a fake atmosphere with a color tint to give it a realistic look. Now all files are linked in description, but if you want to, you can get some high quality from NASA themselves. I will put a link as well for that. You are looking for several images: diffuse, normal, glossiness or specular, clouds and illumination. Finally, most of the images you will find are type of market or projection. But if you're modeling flat Earth, you need to have them in azimuthal equidistance projection centered on the North Pole. Using Photoshop, Affinity Photo or any image software with rectangular to polar filter, you can change this projection. First, resize the image to be square. And yes, it will be distorted. Then apply the filter with North Pole settings if available. Do it for every image you'd be using. If you'll be using Blender a lot, I would suggest learning the hotkeys. It becomes a lot easier, and Blender uses it a lot. Quite often I end up with a different view, as I might have accidentally pressed a key like Tab. So knowing some is useful. Well, Tab is one. It toggles between edit and object view in layout. But for the demonstration, I will try to use the menu as much as possible. So at least you know where those settings are, even if you forget hotkey. First, I will delete all existing items and start fresh, starting with flat Earth. Choosing a shape. Well, we have a circle that is flat, which is different than a sphere. We also have cylinder, and my favorite, plane. A flattened sphere and cylinder is a nightmare to align a flat Earth's texture. It can be done, but it's outside the scope of this video. Between circle and plane, well, a plane can be subdivided, which can be useful later down the line. The issue then becomes, well, a plane is a rectangle. My image has transparent corner, so I'm okay. Make sure you're in Layout tab and Object mode. Then click on Add and choose a plane. I have my view settings up here. We have wireframe view, solid view, view with material, and final render view. Obviously, render view is most expensive in CPU time. But wait, we're not seeing anything. Of course, we do not have any light. Now question, what do you want? If you do not have any light dependency requirement, including shadow, then by all means use emission. But if you want night light, you will need a light source like sun. For now, let's add a sunlight source. Bingo. Now obviously we can change the light direction and even have multiple sun if we choose to, and change the intensity. On this outliner window, we can see all the objects on current scene. We can choose objects either on main view or on this window. Mouse wheel by default zooms in and out. Holding down middle mouse button allows you to move the camera angle. Shift and middle mouse allows you to move up, down, left and right. So let's select the plane. Pressing N or this arrow would expand the handy transform window. You can also access these values from object properties in property window. I will rename it to something other than a plane. I can do it by double-clicking or pressing F2 once I'm in outliner window or from properties window. Put the dimensions you want here. Now as our circumference is 40,075 km, I expect this plane to be equal or more to account for the hidden continent beyond Antarctic. Please note, as it is not real, you will not find that land in actual map. So you will need to update the diffuse yourself. Also make sure that the location says 0 for all three axes. This is the center of our universe. Now let's go to Object, Apply Scale, or Ctrl A and then Scale. This will set our scale back to all 1 and retain the correct dimension. This is good practice and helps with complicated scenes and motion. To texture it, I just changed my main window editor type from 3D viewport to shader editor. Don't worry, I'll hold your hand. There should be nothing here. We click New to create a new material. Give it a name if you want. Instead of explaining this window, let's just use it. You'll figure it out soon enough. Use the Add button from top or the shortcut Shift A. Then either use Search or locate Image Texture under Texture to add it. We have the default setup from New Material, which had a principal BSDF shader hooked to Material Output. This BSDF shader is quite versatile. It can generate a color or get a texture from an image, which is exactly what we are about to do. First we connect color from image texture to color of BSDF node. Just left click on one of those dots, drag it to the other dot and release. Same with alpha node output to alpha input on BSDF. Click on open and choose the diffuse polar image. Linear or smart should work. No other changes is needed. We are done, and here is what we have so far. Skip next couple of chapters if you don't need any bells and whistles. For those of us who wants a bit more, now for our bump. Earlier days I would have gone with a bump node, but I think displacement works better. First we need an image texture. Choose the normal or bump map polar file. Note, though it may not look any different, I will choose color space as non-color, as I am treating it as displacement. Next we add a math node. Note, when you add a node, if you drop it on an existing connection, it will try to update the existing connection. In most cases, it would be correct. Connect image color output to input value node in math. Change math operation to multiply. I will set this multiply by value to 100. Finally, add a displacement node, connecting value output from math to height input node of displacement. Finally, output of displacement will go into displacement input of material output node. We can change the strength of bump using mid-level and scale to change the ridge look, but on its own is not enough for my liking, thus the multiplier. I like the look around mid-level value of 0 and scale of 0.6. Play with it to get the look you want. Next is the glossiness. Let's see what happens. As the camera is moving, you can see the reflection being the same regardless the apparent surface it is hitting. Easiest way to do this to add an image texture and choose your specular polar file. Again, color space is set to non-color. Next is a color ramp node. Connect color output from image to FAC input of this node. Finally, color output node from color ramp goes into roughness input node of our main principled BSDF. Done. This should have fixed our reflection issue. Ground should not be as reflective as water anymore. Now, this will not be very visible on flat earth, but would play much better on a globe. For night light, well, we know the drill. First, we add an image texture, choose our illumination polar image, and set as non-color data. Next is another color ramp, and just like before, we connect color output from image to FAC input. Next, a math node to this color ramp color output to multiply it by 5. Then we add an emission node. Recall from earlier, this is a shader that does not need any light to render itself. Hook up value output of multiply to strength of emission. Finally, we need to add a mix shader. Drop it on the connection between principled BSDF and material output. Basically, output from BSDF needs to go to the top shader input node of mix shader. This mix output will now go to material surface input node. This mix shader, as the name implies, mixes two shader values based on FAC. Now, if those two nodes were other way around, just reconnect one and the existing one would swap. Our emission output will be the bottom shader input node in mix shader. So what is going on so far? We have images on night light. We remap it to black and white using this ramp, which is then multiplied and fed to emission strength, and that output is mixed 50-50. We can change the color of emission manually. Now note how different texture is displayed as I manually drag the FAC slider in the mixture. You can obviously choose a color of your liking, but I like to use the knitter method. That is to use a black body node and connecting the color output to emission color node. And black body allows us to enter a color temperature value. How cool is that? I have mine set to 3000 Kelvin. Now we have the night light, but the problem is it is visible in sunlight. To fix that, we will add a node separate HSV. We need to connect input color node to the color output of our diffuse or main texture. Next, we add a color ramp node. We'll connect V or brightness output from separate HSV to FAC. This time, we are remapping the brightness with finer control of range to use. Connect the output from this ramp to FAC input in our mix shader. All these nodes translates to more brighter a pixel is, choose more from the original set of shader nodes we have created. If it is darker, start mixing this emission layer, which is also based on a mask, resulting in the night light disappearing when a light shines on the surface. Notice as I change the light direction, part of the night light starts becoming visible. Clouds and atmosphere is handled differently. These are actually two different planes above our Earth. For clouds, add a new plane, rename it to avoid confusion, and I made it same size as the flat earth. When it comes to globe, I'll make it a little larger. Again, remember, Ctrl A and choose scale. Next, on earth, cloud can get to quite low from only 2 km from ground to as high up as 18 km. As we will create only one layer, do feel free to create multiple if your heart desire. Set the location Z-axis to a height you want. I'm using 20 km here. To start texturing it, back to shader editor, create new to start a new material. We add an image texture and choose our polar cloud picture. We connect color and alpha output to base color and alpha input in principled BSDF shader. But as you can see, it will hide our earth underneath. To fix that, we will add a mix shader and drop it on the connection between principled BSDF and material output. Next, we add a transparent BSDF, with this output going to the top input of mixture. This will move the principled BSDF output going to the bottom node. We are almost there. We will now hook the image color output to our mixer FAC input. Voila! We have clouds. Now fake atmosphere. I do not know how one would want to handle it. For Earth, it is another sphere a little bigger than cloud sphere. On a flat Earth, will it be a dome? I will show a dome. First, let's hide all the other layers by clicking this eye icon. Next, add a sphere and give it the same dimension as the flat plane. Now we need to split this sphere to make a dome. If you want to keep it as a sphere, just skip the cutting part. Else, change object mode to edit by clicking the menu or press tab to change to edit mode. Next, either choose the wireframe view from top bar or press Z for shortcut menu. Then make sure you have a top view by clicking the Z-axis view. Shortcut numpad 0. Finally, select the box select tool or press B and drag a box over the sphere. Finally, press delete and choose all vertices. This will leave you with the bottom shell. Press tab to exit edit mode or choose it in the menu. We can now rotate this shell on x-axis 180 degrees to have it the right side up. Rename it for easier reference. Apply scale by Ctrl A and scale. Create a new material, delete principled BSDF. We will use a diffuse BSDF node instead. This will give us the color on the rim. As you can see, it is completely opaque. To control the transparency inside the shell, I will add a transparent BSDF and a mixer for these two. Transparent output goes to the top input and diffuse output is the bottom input. As always, mixer output to material surface. Now we have something that is semi-transparent, not exactly what we want. No worry, we will add a layer weight node with facing output node connecting to FAC in mixture. This will allow us to set how much of the atmosphere to be shown. I have blend value set to 0.05 in layer weight. Use that value to make the rim as visible as you want. With diffuse, setting the color. That is all for atmosphere. That is all for flat Earth. One final thing is to group it for ease of use. It would make more sense when you start animating objects. Back in viewpoint, I will add an empty arrow object and confirm it is at the same position as our Earth, cloud and atmosphere. All four objects are at 0, 0, 0. I will rename it to FE root. Now in the outliner window, I will click on my flat Earth model first. Then, while holding down Ctrl key, I will choose Cloud Object, Dome Object, and finally, Empty Object we just added. Ensure Empty is the last item selected. Then we click Object, Parent Object, or the shortcut Ctrl P. That would put all the three objects under my FE root object. Note, if we try to render at this point, we will get an error, as the scene doesn't have any camera to render the scene from. So let's add a camera to our scene. I will show how to move it later, but for now, select the camera and change the location X being 0, Y to minus 400,000 km, and Z to 100,000 km. In rotation, set X to 90 degree, Y and Z rotation is 0. Finally, in Property window, with the camera selected, we will see a camera icon for Camera Specific Settings. Camera type should be perspective. Change the focal length to 22 mm to start with. This will give you a semi-decent view of the whole Earth. Change clip start to 0. It will be set to 0.001 km. Now end value should be more or equal to the distance between the camera and farthest object from the camera. This value is how far a camera would be able to see. This is optimization. I have mine set to a high value of 100 million kilometers. Obviously, if sun is involved, it needs a hell lot more. I also like to change viewport display size. For our dimensions, with current settings, we cannot see the view cone. So if I would make it around 100 km, it is just showing you the way it is facing, and that is all. But in the 3D viewport, this same preference is set from a different place. As you can see, when I am zooming out, all of a sudden it disappears, as it is being clipped. To fix this, either press N or click this arrow button to bring out Sidebar. Under View tab in Sidebar, you can select focal length and clip start and end for your viewport. This is what we see on screen. This time I leave clip start to 100 km and change only the end to match my camera. Now the same modeling with Globe Earth, aka reality. I can hide my entire FE root by holding down Shift and clicking the eye on or off. Using the Shift, it would apply to all child object. Almost everything is the same as flat Earth, except obviously we start with a sphere. There is something else here though. By default settings, our Earth would look rather jagged. So once clicking Add Sphere, locate this submenu on your screen and click the arrow to expand it if not fully shown. In my settings, I'm using a segment count of 120 with rings count of 90. I also set the radius here, that is 6,378 km. Now it will look much smoother. Furthermore, either right-click or from Object menu, choose Shade Smooth. Nice. Now set the scale to 1 by pressing Ctrl A and then choosing Scale, or Object Apply Scale from menu. Remember to name it properly. To create the material now. I have bad news if you had skipped creating Flat Earth model, as we'll copy the whole shader settings from that. With the shader window open, select our main Flat Earth window so we can see all the nodes we had added earlier. Now click A or select All from menu item. All nodes should get highlighted. Press Ctrl C to copy all the nodes. Now click on our art sphere. Create a new material and name it accordingly. Now we delete those two existing nodes and press Ctrl V. This will copy all our nodes from Flat Earth model. Well, it all looks wrong. Don't worry, we will fix it. For all those 4 image textures, we will need to change it to non-polar, meaning marketer version. Do this for all the images. Note that it might also change the color space. Apart from diffuse, all other images should be set to non-color. That is it. Now, similar to flat Earth, for cloud and atmosphere, we will use same method as before, but using sphere. I will add a new sphere. I gave it a radius that is 6,398 km or 20 km above ground. Let's rename it to clouds. Remember to fix the scale by pressing Ctrl A and then choosing scale or object apply scale from menu. Now click our flat Earth cloud and select all the nodes in shader editor by pressing A. Remember that you will see a highlight. Press Ctrl C to copy. Now click Globe Earth Cloud and click New for new material. Name it accordingly and delete existing nodes. Finally, we paste our copied values. We just need to update the cloud image to non-polar version. Remember color space and we are done. Our fake atmosphere is similar to clouds, but the dimension depends on what you like. In my example, I have used a radius of 6,443 km, so it is about 65 km higher up than ground. Remember to fix the scale by pressing Ctrl A and then choosing scale or object apply scale from menu. As always, rename it. Now let's go to our flat Earth environment shader editor. Press A to select all, then Ctrl C to copy. Click Globe Earth environment, create new material and rename it. Finally, delete 2 existing nodes and press Ctrl V to paste environment shader settings. Tweak the settings to your liking and you are done. Finally, I will create a root item to hold all 3 art items. Again, I add an empty arrow object and confirm it is at the same position as our Earth, cloud and atmosphere. All 4 objects are at 0, 0, 0. I'll rename it to Earth root. Now in the outliner window, I will click on my Earth model first. Then while holding down Ctrl key, I will choose Cloud object, Environment object and finally empty object we just added. Ensure empty is the last item selected. Then we click Object Parent Object or the shortcut Ctrl P. That would put all the 3 objects under my Earth root object. We are almost done. Now a quick and dirty star field. Let's go back to shader editor. This time, from the drop down on this panel, from Object, we change to World. Delete the background node and add in an emission node. This is not strictly needed, but if you want to make your stars pop, this is an option. Emission out connects to World output surface. Next, we want a color ramp. Connect color to color. Finally, a noise texture. FAC output of this node will connect to FAC input of color ramp. Now I will change noise scale to around 400 and then play with color ramp until I get something I like. I'm now using a minimum value of 0.736. Emission is left at default, but you can see how it behaves if I change the value. That is it. Well, it has been a long video, so I'll quickly show you how to move the camera. I will select 3D viewpoint on my bottom panel. Next, I ensure my camera is selected. Then, I select View menu on top panel and set active object as camera. This is because I use a keyboard without a numpad. There is a way to lock a view to camera so it doesn't change. Anyway, the top panel would now show what the camera sees. On the bottom panel, you have got several gizmos that would allow you to move and rotate the camera around. You have the top panel to show you the final view. So, be the ultimate photographer. You have the power of God. Move to any place, take any shot. One final look at scene properties to ensure we have correct size of image and a proper output folder. Then just click render image or the hotkey F12 and watch it render. Well, that is all for this video. Thank you so much for watching. If you have liked it and want another one showing animation and better camera movement, please encourage me in comments down below. You can also show your support by liking and sharing this video with others. If you haven't already subscribed, please consider doing so. It would help me bring more contents to you. Thank you once again. Wherever you are, have a safe day. Signing off.